All right, so last we talked, we were applying this principle, the dependency inversion principle. I guess we can start there. The principle just said, depend on abstractions, don't depend on concrete classes, which was separate from program to an interface, not an implementation. And so we want to decouple this concept of the pizza store from the pizza styles. And we were able to do that through the use of the factory pattern, where the subclass got a chance to decide what kind of pizza to make. The actual order pizza method had no idea what kind of pizza was being made. It just passed the request onto the appropriate subclass. Because you called it on a particular kind of pizza store. So there was this man in the middle who had no idea what he was doing. He was just taking a piece of paper and passing it along. And wherever that piece of paper came from, that's what determined what kind of pizza to make. If it came from a New York pizza store, we made a New York style pizza. If it came from a Chicago style pizza store, we made a Chicago style pizza. So we talked about also bottom-up thinking rather than top-down thinking, rather than thinking, I need a pizza store and starting your design at the top like that. You were thinking about my pizza store needs to be able to make a bunch of different pizza types. So that allowed you to start thinking about, all right, well, I need an abstraction for different kinds of pizza. So they should all share some kind of interface. And starting from the bottom up when you're designing like that can certainly allow you to much more easily be able and ready to complete something like this in a way that is extendable. The last slide we talked about was kind of some general guidelines, I guess, to use the term that's on the slide, some general guidelines to follow. So variables shouldn't hold references to concrete classes. Classes shouldn't derive from concrete classes. No method should override an implemented method of any of its base classes. So don't override something to do nothing, or override something that is implemented to do something else. And we mentioned that these were guidelines, not rules. It's not going to be possible to follow all of these guidelines all of the time. But again, just think through and make sure that you know why you're breaking these guidelines. Make it a design decision that you are making off the top of your head. You have reasoning behind it rather than just going with it or doing what seems easy. Questions on anything that we covered last time, the recap? Right. So the factory pattern is actually a couple of patterns. And we've talked about the factory pattern, but now we're going to start diving into the other kind of factory pattern that it's a different pattern, but it is related to the factory pattern. So we're going to look at what we accomplished with the factory pattern, and we're going to see what else we can do to make this better. So we encapsulated the pizza creation process. That way, no one can get in the way in the middle of the pizza creation. No one can insert some logic to mess with that system. Basically, you can think about this like if you were to place a to-go order at a pizza restaurant, a Domino's, a Pizza Hut, wherever, you call in and you give them the order. The next thing that you, the client, do is you pick up the sliced boxed pizza that is exactly your order. You don't have any say about the process. You don't arrive at the store in the middle of the baking process, go behind the counter and make changes to how your pizza is being made. You, the client, place the order, and then you pick up the pizza. And the process that goes on behind the scenes there is it can be outside of your knowledge and understanding. You don't need to understand what happens between the order and the finished pizza. There's a process that goes on there, but you, the client, are outside of that scope. So no one can mess with that encapsulated pizza process. It's very similar to this concept of no outside system can mess with this process because it is encapsulated. There's one thing we haven't really thought about, which is being able to substitute ingredients. You can customize your order, right? You can say, I want a Hawaiian pizza, except I hate pineapple, so it's really just gonna be a ham pizza. Pineapple just doesn't belong on pizza. Actually, I think it's delicious, but I know a lot of people who will fight to the death over that. So we want to be able to customize the actual ingredients in our pizzas to be able to swap out ingredients, take some off, have some kind of customized place for that. So one thing we can note in our design is there is some family of ingredients that goes with each kind of pizza. So the dough can be swapped out. The cheese could be swapped out. The veggies could be intermixed or swapped out. And the meats could be intermixed, taken away, swapped out, whatever we want. But we can place them into these broader categories. And then, once again, each pizza type has a different potential implementation based on its region, which we already dealt with. If we want to be able to extend to new regions, then the ingredients that we're going to be doing should also be extendable into these new regions. So basically, we want something like this. Same product families in different styles. So we're going to build factories for our ingredients. The factory is going to be responsible for creating every ingredient in the particular ingredient factory, or family, sorry. So we're going to have some factory that creates the dough, some factory that creates the sauce, some factory that creates the veggies, the meats. We need a way to handle the regional differences. So something we can do about this. We want a pizza ingredient factory. This is just going to be the interface. We know that a create dough method is going to create the dough. It's going to return a dough object. Create sauce is going to create a sauce object. Create cheese is going to create a cheese object. Create veggies is going to return some number of vegetables in an array. Pepperoni will return a pepperoni object. Clam will create a clam object. So lots of possible classes here. For every possible ingredient, we define some create method or some way that's going to generate that kind of object. Make sense? So we need to, step one, build factories for each region, creating different subclasses of this pizza ingredient factory class. Since this is an interface, we can create a New York pizza ingredient factory, a Chicago pizza ingredient factory, we can see that this is now going to be a lot of work, but also extendable. We need a set of ingredient classes that can be used with that factory, that can be shared among regions. So if we have something like create veggies, we could define something that's shared across the different regions. Since both New York style pizzas and Chicago style pizzas have veggies on them. Then we need to take this implementation and connect it to everything that we've already written that followed the factory pattern. So let's take a look at what the code would look like for the New York ingredient factory. Of course, we implement the interface that we just wrote, the pizza ingredient factory. So what kind of dough belongs in a New York style pizza? A thin crust dough. So we're going to define a thin crust dough class that has a constructor that makes the appropriate style of dough and returns it. Same for the sauce. A New York pizza should be made with marinara sauce. So we will be able to instantiate a marinara sauce class, returning that we will associate with the cheese for our New York style pizza. Veggies. In a New York style, we're going to have garlic, onion, mushrooms, and red peppers. And those are going to become the 4 veggies that go on every pizza, every New York style pizza. We did hard code these veggies. We could make this a choice of some kind where create veggies takes an array, and that array could be a list of strings. Each of those strings could be an appropriate vegetable, and that way people could customize their order by passing this information into the create veggies. It just goes through the associated interface. Same thing for pepperoni. Same thing for clam. And we end up with a New York ingredient factory that creates a default or base New York style pizza with the appropriate ingredients. We then need to worry about reworking the pizza class. So before, we remember that pizza was an abstract class, right? Because it's just a generic pizza object. So it has a name, some dough, some sauce, an array of veggies, cheese, pepperoni, clam, etc. So we still know how to prepare it. But now we've made it abstract because the actual preparation step will vary between the New York style pizza and the Chicago style pizza. So prepare now needs to be written in the New York style pizza or in the Chicago style pizza subclasses that are subclasses of this pizza interface. Or sorry, abstract class, it's not an interface. So cut tells us how we cut the pizza, box tells us how we are gonna box it. Set name allows us to change the name associated with the pizza. We have a get name, we have a toString, and then we have some subclasses. Here are some of the subclasses. So a cheese pizza will extend our abstract class pizza. And a cheese pizza has an associated ingredient factory. When we instantiate this cheese pizza, notice that the constructor takes an ingredient factory object as its parameter. I can't think of the word for some reason. So then we instantiate to set the ingredient factory that is set with this pizza based on the one that gets passed into the constructor. We then prepare the pizza. So we create the associated dough, the sauce, and the cheese. And you can see that nowhere do we specify here what kind of ingredient factory it is. How do we know what kind of ingredient factory it is? It goes through the ingredient factory to be able to produce it. Does that make sense? How that happens? The clam pizza is again very similar to the cheese pizza. We have the ingredient factory. Everything else looks very, very similar. Except that we also have a clam object. So if we make a clam pizza, it's very much like the cheese pizza object, except that we also include clams. Other than that, it looks like an exact carbon copy of the class. Note that though, the factory object may differ. It could be that this is being produced from a New York factory or a Chicago factory. If it's a New York factory, the clams are fresh because New York is on the coast. And if it's a Chicago factory, they'll be frozen because Chicago is not on the coast. There aren't any clams in Lake Michigan. So depending on the kind of pizza it is, we'll look at the appropriate factory for that. But nowhere in here do we know anything about that. It's unnecessary and it's outside the scope of this object. Questions on any of this? Now we need to look back at the pizza store class. So The pizza store, just like before, was an abstract class. And now we're going to create some subclasses for the pizza store. So the New York pizza store will be a concrete class extending the pizza store. So this is going to be the place where we sell those pizzas. Here we actually see the keyword protected for the first time. Why do we think that is? Do we remember what protected does or means? Yeah, which classes? Some classes can have access to this, but not others. Yeah, it's the classes within the same package. So we first make an empty pizza, or you can think of it like a pizza pointer, where basically you say, all right, I'm gonna start pointing to where the pizza is going to be. There's going to be a pizza right there on the table. There's no pizza there yet, but I'm just gonna keep pointing at it until there's a pizza there. There's no pizza yet. When we set it something equal to null, we're basically declaring a place in memory where a pizza is going to be. We basically say, here we have something that is telling us where that is. Then we have our pizza ingredient factory. We can instantiate that as one of its subclasses and assign it to a variable of the superclass. So the pizza ingredient factory is an abstract class. We can assign an abstract class variable type to a concrete class constructor. That's the polymorphism. So we're gonna say, we're gonna make a pizza ingredient factory that is a new New York pizza ingredient factory that then tells us that what we're going to be creating is a New York pizza. It will use the New York pizza ingredient factory, which makes sense since this is the New York pizza store. So we're going to associate a New York ingredient factory with the New York pizza store. We can then go through an if block that's going to figure out what kind of pizza it is. If it's a cheese pizza, we'll make a new cheese pizza. Note that nowhere does the cheese pizza or the ingredient factory specify that it's New York here. How do we know that this is a New York style cheese pizza that's going to use a New York style ingredient factory? Where does that come from? Yeah, when we instantiated the ingredient factory, we instantiated it as a New York pizza ingredient factory. So when we pass that along, the type of object that's being passed along is a New York pizza ingredient factory. The same is true for a veggie pizza or a clam pizza or a pepperoni pizza. Questions on any of this code? So now we have a way to produce different families of ingredients. We had, again, we broke this down into the dough, the sauce, the veggies, and the meats. This is what we're going to call an abstract factory. And this is the second kind of factory design pattern. So it's not a concrete factory because it's not producing actual full kinds of pizzas. It's just producing factories for the ingredients that go on a concrete pizza. Because they themselves need a factory to know where to go. We can make the ingredients, but then we need a factory to decide, is this going to go to the New York store or to the Chicago store? So it's kind of a layered factory. A factory produces the ingredients so that it can be put on a conveyor belt and go to the appropriate factory that is the appropriate pizza store. So it is technically a separate design pattern. In general, we're going to get an interface that creates a family of products. The benefit that we get is the implementation of the family of products is separate from the factory that ships them to the appropriate store. And we can now extend the families of ingredients, and we can extend the different kinds of pizza stores separately. They're not coupled together at all. Does that part make sense? That's a very important conclusion from this, is that we get the ability to extend them separately. So separate factories for products meant for different contexts. Like the New York pizza store or the Chicago pizza store. So the different regions. Some other things that you might apply this to is if you're writing code and you need slightly separate code to run something on a Windows environment or a Mac environment or an Android environment or an iOS environment, then you have the ability to make a factory that ships the appropriate code or does the appropriate thing based on the operating system that it's installed on. So we've used this dummy pizza example, but it very much works, especially if you're designing things for different operating systems, different user interfaces. You can imagine that you might have something like a desktop interface and a mobile interface. If you're on a mobile device, use the mobile interface, and the user interface can just be swapped out at will, and everything else about how the data is stored is all the same underneath the hood, but you now have the ability to swap out user interfaces for people who are using it on different devices. Does that make sense? That's especially important to computer scientists. So this is mostly how this is going to be applied in computer science. But again, it's easier to talk about pizza. It also makes us hungry. So the big benefit of this, we can actually switch out different factories to get different behaviors. So you can swap out your Windows factory for your Mac factory, for your Android factory. One thing that we could do is something like, oh no, for our pizza example, we're out of marinara. We just straight up don't have it. We can switch it out for a different kind of sauce very easily, and then the entire construction of the pizza stays the same. So you change one line of code, and suddenly you're back to producing pizzas. So now that we've gone through all of this, we can once more take on the role of Ethan as he goes into a New York style pizza store and orders a pizza. So first thing we need is a New York pizza store. So the code that will do that is a pizza store, New York pizza store equals new New York pizza store. Again, we're using polymorphism to put a New York pizza store object into a generic pizza store container. We can then take an order from this New York pizza store. So we can say New York pizza store dot order pizza. That takes a parameter, the kind of pizza that you want to order. Since we're saying cheese, we want a New York style cheese pizza with the associated ingredients for a New York style pizza. So order pizza in its implementation calls create pizza via pizza equals create pizza. Here we don't need to know where it came from, right? Because this order pizza is already being called on a New York pizza store object. So when we call order pizza just creates a pizza, but it knows where it's coming from, a New York pizza store. So it can propagate that information. It's on the ticket, basically. It's handed to the create pizza. So since it's called by the New York pizza store, we know that we're going to get a New York style cheese pizza. When we call create pizza, we use our ingredient factory to figure out what's the appropriate dough, what's the appropriate sauce, what's the appropriate cheese that we're going to put on this pizza. So we make a new cheese pizza object in create pizza that's going to say, all right, we want to use the New York ingredient factory to construct this cheese pizza. Great, that will fill this pizza, which then gets returned to the order pizza. So as we do this, we prepare the pizza, which goes through the prepare method that's going to create the dough. Since we're using a New York ingredient factory, we know exactly what kind of dough we're going to create. That's the thin crust. We know exactly what kind of sauce we're going to use. That's marinara, because that's defined by the concrete class, the New York ingredient factory. And the same thing with the cheese. We know that it's going to be Reggiano cheese because that's the cheese that's dictated by the concrete class in the New York ingredient factory. Finally, with all of that done, we go back to order pizza. So create pizza is done. It's returned to this pizza object. That is a New York style cheese pizza that adheres to the New York style ingredient factory that produced all the ingredients for the New York style cheese pizza. We're all the way back at order pizza now. We can do everything that we need to bake it, cut it, and box it and be ready to go. So that's kind of the call chain as we go through this entire process. And note that this process is now extendable in any of these ways. We can create new kinds of pizza. We can create and modify new kinds of ingredients. We have full creative control now over this pizza store. We can do lots of things with this, and it's very extendable. So we should certainly pause here and make sure that everything is clear. Does anyone have any questions or even just kind of a general, I don't really know what's going on? Any of that I'd like to hear so that we can clarify any confusion.
I'll get there.
Anyone, anything?
I'm not like usually add no extra cheese.
Yeah, we don't really have an easy way to do extra cheese, but it's something that we could extend in this, right? As an ingredient factory, we could easily swap out the Reggiano cheese for extra cheese or extra Reggiano cheese. So yeah, that's something that we could easily add to this structure. And then wherever you allow for extra cheese, that could propagate to every other kind of pizza so that any pizza could be ordered with extra cheese. So in general, the abstract factory pattern, so we're going to kind of zoom out from talking about pizzas, talk about where else can we apply this and giving it an actual definition. It provides an interface for creating families of related or dependent objects without specifying their actual concrete classes. So here is the general code layout, the general UML for an abstract factory. So the client in this case was someone like Ethan from the last example, where someone's going to go request a pizza. The client calls the abstract factory method the create product A or the create product B, something like I want a New York style cheese pizza, or I want a Chicago style clam pizza. Something of the sort. And then we have our concrete factories that are realized from that. So again, we have realization there. So that is what creates the actual, those are the factories using the factory pattern. We also have an interface for the abstract product type. This is where the pizza was. And then we have the product types for each of those. The concrete factory 1 is capable of producing the product, all of the product A's, and the concrete factory 2 is capable of producing all of the product B's. So each factory can produce an entire set of products in different ways. So we've abstracted the concept of the factory to now be able to produce families of related products rather than just a single kind of product. So before we had a factory that produced a New York style pizza, now we have an abstract factory that produces a customizable kind of New York style pizza where the ingredients can all be swapped out. The process can be modified. So this is the generic UML for abstract factory. So here it is with the pizza example. I'll scroll through this a little bit. So we have the pizza that calls and uses the pizza ingredient factory. What is realized from that is a New York pizza ingredient factory or a Chicago pizza ingredient factory that all has the same methods that produce them in different ways. Each one of those can use all of the different toppings or sauces. So we have a cheese interface with the different kinds of cheese. We have a sauce interface with all the different kinds of sauce. We have the dough interface with all the different kinds of dough. And now the New York pizza ingredient factory just selects from the appropriate ingredients what it means to make a New York pizza. And the Chicago pizza ingredient factory selects from that same list of toppings to be able to produce a Chicago pizza. Each factory produces a different implementation for this family of related products, all of these toppings. So hopefully this clarifies a little bit the difference between, and this is on the same slide, so you can refer to this later, the kind of abstract of what an abstract factory looks like in general, and the concrete, how it applied to our pizza example. Questions on this linking up of the abstract idea from the concrete implementation that we went through? Note that it's decoupled. We could add a California pizza ingredient factory and it would interface with all of our existing toppings. We could add new toppings and that wouldn't break any of our existing factories, but we could go back and change those factories to incorporate the new ingredients that we add. But the fact that we're just adding those ingredients does not break anything that already exists. So each method in the abstract factory looks like a factory. Create dough is a factory for creating dough. Create sauce is a factory for creating sauce. Every time we declare these abstract because we have options for creating the dough and creating the sauce. These methods are often implemented as themselves factory methods, which is why we kind of call it an abstract factory, is the implementations of these methods are going to be factories. Every single one of those methods is responsible for creating a single concrete product. So create dough creates a single dough object from a list of possible dough objects. Create sauce creates a single sauce object from a number of possible sauce objects. We just have to define what family is used in a particular type of factory. So using factory is a very normal, commonly used way to implement these methods. One thing that gets very frequently confused is the difference between the factory and the abstract factory. So I wanted to take just a little bit and kind of show them side by side so that you know the difference between the factory and the abstract factory patterns. The factory, zoom in on that. So it provides an interface for creating a single product, a pizza. Not a pizza with a bunch of ingredients. We didn't have that functionality when we were talking about the actual factory. There's a single product that a factory is responsible for producing. The subclass of this pizza store decides what concrete class we're going to be instantiating. So the New York pizza store is going to create the pizza belonging to the New York style. The pizza store has no idea what that is. That create pizza just gets passed down to the appropriate kind of store that you instantiate it with. Remember that since pizza store is abstract, you can't make just a pizza store. You have to make a New York pizza store or a Chicago pizza store. As you do that, now there's only one way to create the pizza, the New York style or the Chicago style. We instantiate these different kinds of subclasses, the different kinds of pizzas that we could produce based on where it gets called from. So we can end up with a New York style cheese pizza, a Chicago style cheese pizza, etc. That creates an actual pizza that gets returned to the pizza store. Clients don't need to know any of this. They just instantiate the appropriate kind of pizza store and then make the appropriate kind of pizza. And all of this is encapsulated and hidden behind their knowledge or understanding. It's very much like ordering a pizza on the phone. Whatever happens between that and picking it up, you don't need to know that in order to be able to enjoy your pizza after you call it in. So all of this is the internal guts of how this system works. The client makes a pizza store, orders a pizza, done. On the other hand, an abstract factory isn't for a single product, it's for a family of related products. So the ingredients of a pizza is a family of related products. We have the dough, the sauce, the cheese, the veggies, the pepperoni, the clams, etc. We then make different factories for each of the dough, sauce, cheese, veggies, pepperoni that are able to select from the appropriate kinds of each of these objects as they vary. So the dough varies between the New York style and the Chicago style. The sauce varies between these styles. And each of those can be implemented as a factory because it is a single object. It's not a family of related products. It's a single product. So each one of those has their own associated interface, their own associated set of concrete classes for all the different kinds of dough, all the different kinds of sauce, all the different kinds of clams, different kinds of cheese. And those are, as it says here, parallel sets of product families. So two different patterns that are kind of interrelated and are very important. Anyone with questions? This will be the next mini lab that you get. There is a factory mini lab, but I'm not going to worry about that until at the very least next week. And possibly even the week after. I think we have a little bit of flexibility. So talking large scale schedule at this point, I'm going to start covering these patterns at a bit faster pace. And there will not be labs associated with each of them. In fact, I think factory might even be the last one aside from observer. I think we're going to eventually have a small observer lab, but there are basically only two of these smaller stew labs left. And then we'll have two of these larger projects that we'll be working on. This one and one more that utilizes some of the ones that we're going to be, the design patterns we'll be talking about over the next week or two. So that just kind of gives you a sense of where we are. We'll have covered quite a few of them before the next exam at the end of week 9. That will probably be a very design patterns heavy exam that will be querying and looking at your understanding of a lot of these patterns.
So that was 5 small labs and then 2 of the large scale ones?
Yeah, and the larger scale ones will be worth 3 times the weight of the smaller ones. Yeah. So what that means is each small lab is worth under 10% of the labs category of the class, and the big projects are worth more like between a quarter and a third of that. So I'm also going to try to be somewhat lenient on the smaller lab grading because I know that some things aren't precisely clear. You have to go back and try to make everything work. It doesn't quite flow to the level that I would be happy with. So what that means when I go grade it, I won't hold small things against you to that same extent.
Is it on purpose? The APIs is missing stuff?
I don't think so.
I saw construction today while I was working on Builder, and it's just like, this is the constructor. right? Do we need parameters or anything?
We need to spend more time as a department. If this is going to be the labs that we assign, we need to spend some more time on them. I wish I had time to fully redesign them ahead of delivering them, but I do not. So, one, I apologize for the extra work and stress that causes you, and two, I will keep that in mind when I grade it.
You want to hear a really dumb mistake? I saw the superclass as object and like, oh, I'm gonna go and say implement or extend object.
Yeah, nice. Luckily, we get that by default, for everything naturally extends object without having to specify it.
20 minutes later, I felt like, yeah, it's just built in.
Yep. Yeah, that's a good thing to recognize and know for the future. I've seen and heard much sillier things. But I think in general, if I'm giving the class a little bit of feedback, I don't know if I see enough of you in office hours or with questions. I know that these labs have a little bit more to them. So just remember that my office hours exist. I'm happy to talk to you. I'm happy to help walk you through any questions that you have. And I apologize if you email me and I can't quite get to your questions in as short of a time frame as I would like. But as usual, I will hold myself to that 24-hour mark. It just might be closer to that 24-hour mark than I like. I like to be able to respond to things if possible within 5 minutes. But that's not always the case. Can't always do that, but I'll get to it as soon as I can. If you have a very important question, office hours will get your question answered faster than an email. Any other questions or concerns? I don't really want to hop into thinking about the next design pattern quite yet. So my plan is for tomorrow, I guess, to be a work day. Would we prefer a work day or a Caddis/Project Euler day? I'm assuming more people want work days. So, yeah, I'll be available for that. We can get you through anything that you're stuck on with regards to the Builder Lab. I would also like it if someone, I don't care who it is, someone has some kind of UML for the big project that they would like some feedback on. I'll have you come draw it on the board, and that way the entire class can poke holes in it, I can poke holes in it, and nobody's judging anybody on the state of that, but I think that will help you to be able to get started, and it will help everybody else in the class to see what they should be thinking about as they design that. We can do that for multiple different people in UML diagrams. So if you're able to produce something by tomorrow, we can get you some feedback on your project design. Excellent. So we already have multiple people. So that's good. If you would like to add yourself to that list, come with something prepared for tomorrow. And we'll look at it and get you some feedback. All right, see you all tomorrow.
No.